C part. Calculate the perimeter of the equilateral ABCD. Again, I will move to the previous page. Let's make some space and then we will solve it. Okay, so students, I hope so you all of them are familiar with the perimeter. What is perimeter? It is basically the outer boundary of the any figure. So here, if I take the blue color, yes, let's take the blue color. Okay, so this is our ABCD equilateral. This is our whole boundary, right? So what we need to do, it means perimeter equals to AB plus BC plus CD plus DA, right? The whole outer boundary. I am writing the same thing here. Then we will discuss how we will calculate each factor one by one. AB plus BC plus CD plus DA. Okay, now see which quantities we have and which we need to find out. Okay, let's again raise it. And also I think you should raise it, this one, because the formulas are long. Okay, so AB we calculated in part A, right? This one we calculated it in part A. We know its value, I think 8.09 something. Yes, 8.09. Okay, this is known, right? So I mark it as tick. This is known, we know that 8.09. This is also known, right? So we left with BC, that is not known, and AD, that is not known. Okay, so one by one we will discuss it, in which way we will find them. The first thing is, let's discuss the AD, this one, because it lie on the right angle triangle that makes the angle of 90 degree. So in that case, if I apply the trigonometric quantities, trigonometric identities, we can say that AD equals to base by hypotenuse, right? This is our base. If we are taking the angle 34, sorry, not AD, I am telling you that okay, I am shortcutting. Okay, I think we should write it in this way. Cos theta, let's apply the equal trigonometric identity. Cos of 34 equals to base by hypotenuse, right? So here in this case, base is, why it is not right? Okay, base by hypotenuse. So in this case, base is 12 divided by hypotenuse is dA, right? So how it will be calculated? dA equals to 12 divided by cos of 34, and it comes out to be 14.4746, right? 14.4746. So dA is given, we calculated dA, we know. I am just writing the quantities that we calculated, right? So the first one is AB, and it is 8.09. BC is not calculated yet. Okay, we'll take some time. I am just making some space for that one. Okay, then CD is 10. Yes, 10 is given, plus DA we calculated 14.4746, right? Okay, now what we need to find out? We need to find out BC. Okay, go back to the question, making space, and then we will do it. Okay, so for finding the side BC, this one, we use the cosine formulas, cosine laws, and it is for finding the any side of a triangle. Let's suppose it will be a side. Let me, if I call it the a side, it is equals to square root of b square plus c square minus 2bc cos of theta. Tan square plus, let's suppose this is 10, just substitute the values. This is b with 10 and c with 12 and the angle between them. 10 square plus 12 square minus 2 times 10 into 12 cos of 56. Substitute all these values in the square root, right? These are the whole, this whole formula is in square root. So it comes out to be 100 plus 144 minus 20 into 12 will give you 240 cos of 56, right? It is in the square root, so we get square root of 244 minus 240 cos of 56. Just substitute it in the formula and you get the value 10.4782. 10.4782. Okay, we will substitute it. BC 10.4782. So when you guys add them, you get the final answer 43.0428, and if we will round it off, we get 43 meters. So basically this is the perimeter of our equilateral A, B, C and D. Okay, now read the next part, D part. Calculate the shortest distance from B to the line AD. Where is the line AD? Again, go back to the previous page and make the space. Oh, sorry. Shortest distance from B to AD, right? So always whenever in the question they ask you for the shortest distance, it must be a perpendicular line to that perpendicular distance to that line, right? So I think it is not seems like a perpendicular. We should like this one. This is almost perpendicular, makes an angle of 90 degree, right? So if you consider this figure, let's suppose ABD, we can say E, let's suppose E. So BE is basically the shortest distance. Okay, so again we will use the trigonometric identities, and by using the sine theta equals to perpendicular over hypotenuse. So in this case we will take the triangle, this one, this triangle, right? BDE, BDE. In this case, our perpendicular is sine is again, angle is again 34, sine 34 equals to perpendicular is BE and hypotenuse is 12, right? Just cross multiply it, you get BE is equals to 12 sine 34, and from here you get BE equals to 6.710. You get 6.77 or 71, whatever you want. So this is the shortest distance from point B to the line AE. So this is the answer for question number D, 6.71. Well students, thank you. Allah Hafiz. Bye bye.